and basically we are going to engage in a little bit of more mathematical proof knowledge. I don't want to say proof techniques just yet because I feel like in this portion we're going to learn a little bit more about like equivalence classes, relations, and equivalence relations. So I thought I would cover some of that today. Well, not cover, but basically learn a little bit more about that because apparently I saw that there was this lecture series on YouTube by I'm trying to remember the lecturer's name. I think it's Frederick by Frederick Sculler, I think that's his name. Apparently he's a theoretical physicist, and this course that he taught, like, you can find this on YouTube actually. It's called it's on top here. It's called, well, you guys can't see it. I just realized that the chat's there. It's called Geometric Autonomy for theoretical physics. So I thought I would take a look at it, and it's funny because I remember Sasha was teaching me a little bit of math, a little bit about proofwriting during the beginning of the summer, and I end up running into the same stuff that he taught me during that time. So I thought I would solidify my knowledge a little bit on those things. And in this section, this was about like sets. It goes over the Stremillo-Frankel axioms of set theory. So I remember like Sasha teaching me this, and I think like this helped solidify it because I actually had like the axioms in front of me and actually reading how they work. Now that doesn't mean I understand it. It's just that I felt like, oh, okay, I'm kind of familiar with some of the material. So I was like, oh, okay. So I thought that was pretty cool. The third lecture was basically about classifications of sets, and I think he introduces a little bit about functions, but mainly about equivalence relations and equivalence classes. So I thought that was also pretty cool. But I don't think I'm ready for the next set of material, which is basically topological spaces and the construction and purpose. So I don't think we're ready. I don't think I'm ready for that yet. So, but I'm just basically gonna get started on some equivalence relation problems. So let's start with the first one. Well, I think mainly the first part is going to be relation-based problems. Not going into equivalence yet. Oh. Why did it double up like that? That is strange. Let's put this over here. Okay, why does it keep doubling up like that? Oh, it's just two separate ones. What the heck? That was weird. Oh well. I thought they were connected. That's why, like, I got rid of one of them. Okay, so let's get started here. All right. Let A be set. I'm just rewriting it, so it's just like a muscle in my brain to basically say I've written the information down. Write the relation that expresses. Okay, so we gotta write the relation that is. Well, I put the equal sign there. I probably shouldn't do that, but just to indicate that that's that on A. So the relation. So we can have 1 and 0. No, wait, hold on. Strike that. Reverse it. be read from left to right, so... Yeah, so, oops. Like, now, because I'm worried that, it's gonna be read like, because I know it's supposed to be from left to right, so... I don't know why I'm, like, blanking out. I think it's because we're writing it in a different way where it's supposed to signify this, so it's like, that's... And here, 2 to 1. Then we got 3 to 1. So we're gonna have a lot of writing here, because it's gonna be a big set here. I should say. I want to make sure that I didn't miss any of one of them. Yeah, and I think that's what we get. I'll probably do like then illustrate it with a diagram. Okay, so 1, 2, 3, oops, 3, 4, 5, oops, okay, alright, oh, and we also have 0, oh, wait a minute, hold on, I almost forgot another bunch of numbers, I mean a bunch of pairs. So we should have 2, 0, 3, and 4 greater than 0, and then 5 greater than 0. Okay. Okay. So we don't have any other room, so now we gotta diagram everything. So now I'm trying to remember, does the arrow point at, because it's supposed to be 1 is greater than 0. 2 is greater than 0, and greater than 1, which is also greater than 0. This is going to be a lot of writing. 3 is greater than 0. 4 is also greater than 0. 5 is greater than 0. But also 3 is greater than 1. 4 is greater than 1. 5 is greater than 1. And oh, we already have that arrow. So erase this one. Then we also have 3 is greater than 2. So now we have 4 is greater than 3. Then we already have that one and that one. And 4 is greater than 2. Greater than 2, greater than 1. 5 is greater than 2. 5 is greater than 3. And 5 is greater than 4. Oh, that's actually a pretty nice design. wonder if like whenever you draw relations like this, maybe they make nice little knots like this. Well, I call it a knot, but it probably shouldn't be called a knot, but it looks cool. I guess this is the visual way of looking at math, but the diagram does look pretty cool though. I ain't gonna lie. Because it's funny how it looks symmetric, like, well, it doesn't look symmetric the way I drew it, but like the way that the lines go, it kind of, it shows symmetry. Visual symmetry actually, which is pretty cool. Shows you like how math can like really blow your mind with the relationships it has, right? Okay, so I think we're gonna do number 2 now. Alright, so what do we got for number 2? Wow, it's like doubling up like that. I don't know why it's doing that. It's copying it twice. That is so strange. Oh well. Okay. Now we have to set a 1, 2, 3, 4, 5, 6. Actually, now we'll check our answers like probably like after number 3. I usually like to do a couple of them before we move on. Alright, so write out the relations and express in divides. Okay, so this one's going to be a little bit more thinking involved. So, the relation now the question is that does this involve prime numbers? And I'm guessing it does because like we only have these numbers here. So I'm guessing do 1 divided by 1, 2 divided by 1. After that, so 4 divided by 2. I think we can do 6 then. So 6 divided by 2. But then 6 is also, we can divide it by 3. Diagram everything. So I wonder what this one will look like. So we got 5, which is prime. So alright. So I think that's basically all the ones we can divide into. Hey, Roman Dish. What's the best part of your day so far? And also guys, if you're tuning into the Twitch stream or like the YouTube live stream, for Twitch, if you like math or physics and you want a study stream to keep yourself productive, whether it be you're doing an art project on your computer or whatnot, or just doing some research or whatever, drop me a follow. If you're watching this on YouTube live and you're doing the same exact things, you know, hit the sub button and also hit the like button down below. It keeps motivating me to keep making more content for you guys, as well as do more math and physics to benefit my own interest in the subjects. Yeah, this diagram looked really nice. I like how, like, I mean, it's math and symmetry is important, but the symmetry in this diagram, I'm like, wow, wasn't expecting that. but it looks really pretty. So I think, let's see, express the divide, so I think that's how it goes. Now, wait, I have to look back at the way this division symbol is, because I forgot that it's either the denominator that's on front and the numerator on the back, or is it the same way as a fraction? Counting. I think it's sets. We got subsets. I just need the divisor symbol. But I forgot where they introduced modulus, because I think that's when they started introducing it. Here we go, the division algorithm. I know that one's going to be important for mods, like modulus. Or modular arithmetic, sorry. I remember, where is the division symbol? Maybe I have to look at the index. Oh, I didn't know you could do that. Cool. All right, here we go. Suppose yeah, I thought so. It's reverse. I knew something was kind of fishy, so let's take this definition so we don't forget it again. Paste it here. I don't know why it's doubling like that. Okay, so I think we gotta rewrite these. So we're gonna have to rewrite it the opposite way. Just erase the whole thing. Oops, didn't mean to erase that. Okay, let's erase this. Paste. There we go. Alright. Now let's write this set all over again. So yeah, the denominators first and the second. So and 1 to 2, 1 to 3, 1 to 4, 1 to 5, 1 to 6. And after that we have 2 to 4. And 2 to 6, and 3 to 6. Okay, we don't have 0. Okay, so then I don't think there are any other ones that can divide into each other. Okay, now we have to diagram it. So let's do 1, 2, 3, 4, 5, 6. Let's do it the same way we did last time, because I think the way you rearrange the numbers is also dependent on it. Actually, let's have more fun. Instead of doing it like that, let's do it like let's make it into a nice little shape here. So let's do it this way, and then we can let's put 4 here, 5 here, and then 6 here. Okay, let's see how this goes. So 1 goes to 2, and then, but 1 also goes to 3, which also goes to 4, which also goes to 6, which also goes to 5. Okay, now let's see, 2 2 goes to 4, and then 2 goes to 6. Oh, I don't like the way I drew that one, so erase that one. Goes to 6, and then 3 just goes straight to 6. I mean, it kind of makes 2 triangles, but at the same time, it's like, it doesn't look very symmetrical. Actually, let's have a little fun, and like, let's see what happens if we did it on this one. So, let's do it this way, and then, oh yeah, we have 0 in this one, so. Actually, maybe we can put 0 in the middle. Let's see how that works. And then we'll put 2, 3, and then 4 and 5. Let's try that. Let's see how that goes. So all these numbers are going to be greater than 0. Then 2 is greater than 0. 3 is greater than 0. And this one, 4 is greater than 1. 4 is greater than 2. Greater than 5, actually. Hey, and Stunky, how's it going? Actually, I will give Stunky a shout out on Twitch. If you guys are not familiar with Stunky, he is also another math streamer slash, I guess like computer science or computer programmer, I should say. Like he also does research involving computer programs. So, and Stunky. I always forget what you do with computers and Stunky. I know you do math, but also I know you also do research involving your computer and stuff. So I'll give you a shout out. There we go. Yeah, we're working with relations today. Right now I'm just playing with like the relation that we developed in the first question. I just want to see what type of diagram we get. So, okay, so 1 is greater than 4, 1 is greater than, 1 is less, so it's like greater than, so basically like when we have 1, it will just show that the relationship's here. High energy this morning, loving it. Nice, nice, that's good. Okay, so if we're going for 2, so 2, just go across for 3, then 2 is less than 4, 2 is less than 5. And then we have 3. 3 is less than 4, 3 is less than 5. And then now 4 is less than 5. Okay, so they both make a like the symmetry's still there, but I think it's like interesting like how it's like despite how we rearrange the numbers, like the way we wrote them here and when we wrote them here, there's still a symmetry here, which is really cool. I mean, this one I kind of like better because the way it just makes this little cross here, but it's just funny how this one makes a bit of a crisscross when we put the 0 in the middle. I mean, if we put the 0 somewhere else, like maybe if we put it here or maybe like, you know, I think there still would probably be a symmetry there, which is really cool. Who says you can't combine art with math? This one I think we just kind of like I think we just tried it out, but maybe if we rearrange it in a different way, maybe that will probably get something that looks kind of close to having like some sort of symmetry, I guess. Who knows? I mean, I could try to play with it. Let's do it like we did with our first one, where it's like 5 and 6. Okay, so 1, divides into 2, 1 divides into 3, 1 divides into 4, 1 divides into 5, 1 divides into 6, and 2 divides into 4, but 2 also divides into 6, and 3 divides into 6. I guess division is like similar to subtraction. It's kind of asymmetrical in some way. I mean, it looks cool, but at the same time, it's like, oh, there's not really like a shape forming like in this one. But maybe that's an observation we can make. Oh yeah, gotta go back to the original page we were on. So, relation properties. That's 11.2, 11.1, here we go. Alright, next one. Number 3. I don't know why it's doubling up like that. Oh well. If we just get another one, I'll just like get rid of the duplicate. Okay. So express equal to or less or greater than. Okay. So A is 0, 1, 2, 3, 4, 5. And then R, the relation. Okay, so I'm guessing it's going to be read from left to right. So I think like the lower number is going to be, no, the greater numbers is first, and then the lower numbers afterwards. So we can write, oops, no, I'm writing reverse. 1, then 1, 1. Then we go into 2. So 2, 0, 2, 1. Then 2, 2. Then after that, we can have 3, 0. And then 3, 1. And 3, 2. And then 3, 3. Then we can go into 4. So 4, 3. And then 4, 4. Oh, woof. Kind of jumped ahead there for a second. Because we gotta do 3, 0. And then 4, 4. And then now we gotta do 5. So 5, 0, 5. 2, 5, 3, 5, 4, and then 5, 5. Okay, so we got a lot of combinations here. So we have 6 numbers. So let's try this design. Okay. And next we have also have one that goes to itself. Oh yeah, and we also forgot one more. The most obvious one. So we can have this do that. So actually all of them should have one. Okay. Alright now, so already 2 to 2 here, so 2 to 0, and then 3 to 2, then we have 3 by itself, so now we have 4, so 4 to 1 we can do here, then 4 to 2 right here, and 4 to 3 right here. We already have 4 to 4 here. So then we have 5 to 0, which is already done. So we have 5 to 1. And 5 to 2. 5 to 3, and 5 to 4. Yeah, it's kind of a cool looking picture actually. Now of course when they say diagram I'm probably not doing it right, but at the same time I'm like, ooh, that looks pretty cool. I think that's like, I'm just as fascinated by this as when I saw like I think I don't remember what they're called, but they're like diagrams on how you can get kids to like remember the multiplication tables. I don't know what they call those little drawings, because I think like when you do 1, it looks like it has some sort of polygon shape. I don't remember which polygon it was. And then when you do like 2, it looks like let's see. 2 times 4, and like it's like a special way to like help kids remember the multiplication tables through pictures, and that's what this kind of reminds me of. I mean, what I'm doing, but it probably is not what the question is asking. So maybe speaking of that, we should probably look at the solution. So we have 11.1. So I'm probably not drawing the diagrams right, but I find it very fun, like to do it that way. Just to see how things go. I mean, did you guys ever do that? To basically just, like you saw a mathematical pattern and you're like, let's see what this mathematical pattern looks in another format. Chapter 8. Chapter 11. Chapter 11. Where are you? Here we go. Ooh, that's pretty. I mean, it's not exactly what we did, but kind of looks the same. Kind of cool though. And we had this for number 3. Number 3 doesn't look exactly the same, but at the same time it kind of like gives that same spirit. But it's still cool. It still looks cool though. I guess they just don't put numbers in the middle, but even with a number in the middle, it still looks pretty cool. Because it forms like a very cool symmetric shape. Maybe that's a proof. Maybe that's a proof in math somewhere. So I don't know if we should just keep going down. Well, the next one looks like it's supposed to be a question of its own. Let's see. Here's a diagram for the relations R on A. Write the set A and R. Oh, okay, that one. That one kind of looks like it's kind of like a fun one. Well, when I say fun, I mean like it's like visually appealing. Because now we got a picture and now we got to decipher what it is. So we know that the set A, in this case, is going to be 0, 1, 2, 3, 4, and 5. Yeah, because that's 6 there. I have a physics problem. Oh, hello. Voltra? Welcome in, welcome in. Sure. After all, this is MathSpellBook, so I also love to do physics too. So I will try my best. I will try my best. So let me see. I just want to, like, while you're typing that out, I'm just gonna finish this problem. Voidic? Okay, I tried to find it from my book. I mean, it's not the hardest, but it was really fun. Oh, okay. I'm into fun problems. So the way this relation looks like it's 0, 0, then 1, 1, and then 2, 2, and then 3, 3, and then 4, 4, and then 5, 5. And the way this relation works, it seems like 4 goes into 0, so it looks like 0 and 4 are paired up. And then we got 1 and 3, and then 3 and 1, and then this side we got 2 and 4, and then 4 and 2. Yeah, and then lastly we have 1 and 5, and then 5 and 1. That's a cool shape though. Actually, it's kind of cool, like when you like do math and you just look at a picture and you realize, oh wait, I understand what this shape is telling us now. I guess the reason why I like math is that when it becomes visually appealing, it's really visually appealing. And then like if you're able to discern something abstract, like, you know, pulling numbers and the way to write them out from like something like this, I think that's pretty cool. I bet you, like, even if you didn't have numbers here, you could probably replace the numbers with something else, and then it would be just as like, I don't want to say solvable, but just as like kind of like interesting to figure out based on that. But of course you have to have the thinking. It's like, oh wait, if I put numbers here, I can write it like this, and if I do it like this, then I can write it like this. You know, stuff like that. So actually, Volta, like, because I noticed that Enstunky called you Voldig. I don't know what name you go by, but let me know what name you go by so I can address you correctly, the way you want to be addressed. Because I want to make sure you feel respected and welcome here. Because I see you are a first-time chatter in our chat. So I can't wait to actually see what problems you have in store for us. Walter's fine. Okay, I'll call you Walter. Actually, Walter's a cool name. Even though it may sound like kind of basic, but at the same time, it's like it's a cool name for me because like I think like there's certain names like Skylar. Let's see, we have Skylar, Cyril. Like there's so many cool names in the English language. Okay, what do we got? Ooh, this one looks like a long one. Okay, so a small point-like speaker is suspended in the air. Oh. So if you guys are watching this on YouTube Live, the problem is up. Walter posted that up, but I will copy and paste that. Where's my mouse? Oh, here it is. Oh, nice. Actually, I like this font. This font looks cute. So thank you, Walter, for the problem. It is a really fun one. I actually am from Finland. Oh, from Finland. Oh, okay. What's it like in Finland, actually? I don't travel much, so whenever people tell me they're from a place outside the US, I just always have to ask, what is it like in your country? Okay, so we have I think we can just have fun. We can just draw a little speaker here. My drawing is not that great, but we'll settle with it. So above the surface of water. Okay. So we'll just write water here. So this is 8.7 meters. It emits a single frequency of sound towards the calm surface of the water. Okay, so maybe the speaker should be pointed down, I think. Right? So let's see. A small point in the speakers is suspended in the air above the sea. So let's just draw this speaker right here. I mean, I know it doesn't look like it. Actually, that's worse. That's way worse. We'll just make a triangle for the little speaker. Finland is really cool. I really enjoy it here. It's pretty peaceful and I enjoy living here. Nice, nice. That's good. That's good. At least you're in an atmosphere where you're like feeling relaxed and calm and everything like that. That's good. Always enjoy your inner peace. And now you're here sharing an awesome problem with us, so I thank you. From the US. Okay. So it emits a single frequency sound towards the calm water surface. The wavelength of sound. Ooh, okay. I remember we were doing waves like a while back, so I think this might be interesting. So the wavelength is, oh no, I have to convert, don't I? Yep, I gotta convert it to meters. I mean, I don't have to, but I prefer to do that because sometimes I just gotta deal with it. Okay. And in the water it is, oh, that's okay, so maybe we should write in air, and then the wavelength in water is 3.4 meters. Okay. Calculate the frequency of sound and the area on the water surface through which the sound can enter the water. Oh, okay. So what I remember, I believe, now I'm trying to remember the equation, because I know frequency has a relationship with wavelength, and I think it's the velocity of the wavelength that equals the frequency. I believe that is the equation. So, so the question is, the speed of sound in air is Okay, so we didn't write v. I thought we did. So this is that in air. So velocity in air. Calculate the frequency of sound and the area on the water surface through which the sound can enter the water. Okay. So I think calculating the frequency of the sound is going to be a simple procedure. And the area of the water surface. Okay. So I think basically we should do the stuff in the air first, and then we can do the stuff involving the water, because we don't know the speed of sound within water. That's the one thing we have to figure out. And I'm thinking the problem is going to make you try to figure that out. Okay, so okay, so we're going to write this as frequency in the air, FA. So now I'll take out my trusty calculator. So the frequency in air is 0.78. Then you multiply that by 343 meters per second. And you get a frequency of 2.267.5. I'm guessing you multiply these two together, so it's meters squared per second. Now I think in frequency that's hertz. I think you. Now I'm trying to recall everything I learned from about frequency and waves. Actually, you don't need the speed in water. Oh, okay. Why is that? Hey, Sasha, how's it going? Yeah, it's funny thing, Sasha. I remember you were teaching me math like at the beginning of the summer, and I happened to find this course like on YouTube. Well, like lectures by this professor. I don't know if you're familiar with his work. I think his name is Frederick Sculler. I think that's how you pronounce his last name. And it was funny because like when I was watching his lectures from 1 to 3, he was talking about the stuff that you were teaching me, like the Zermelo Frankel axioms of set theory, in addition to equivalence relations. So I thought that was pretty cool, and I was like, okay, now I have notes I can solidify this knowledge with. I think the next lecture is supposed to be on topological spaces. Okay, so let's get back to Walter's problem. Okay. Okay, so we got hertz here. Alright, so that's the first part. Calculate the frequency of sound and in the area of the water surface which it goes through. So if it's a speaker, then it's gonna go like kind of like this. Now the question is that and the sound waves are gonna be like something like that. I know that's not probably the right way to draw it, but you know, I got a course in functional analysis. It's boring to death. Oh, why do you need functional analysis? I think I asked you that question, and I don't remember the answer why you're taking it. Because I remember I told you about functional analysis, and you're like, there's not much. You don't really need to know that. I mean, you said that. Like, I think you said it in that type of way, and I thought, oh, okay. I thought it was going to be important, but I guess not. And thank you for the follow, Walter. I really appreciate it when you guys drop the follows, because it keeps me motivated to continue doing more math and physics content with you guys. And plus, like, if you guys like basically love math and physics and you're already like studying math and physics on your own or like at school or something, you guys educate me as well. So I feel as if like I'm learning with you, if you don't mind that, of course. Because math and physics are just hobbies of mine. I'm not in school or anything, or I'm not teaching it. I'm just basically learning on my own. Hence why it's called MathSpellBook, because I'm trying to spell out math for myself, or learn the spells of math, as it were. I thought it was more advanced stuff, and teaching is assigning all the exercises in the book. Oh, okay. So it's like one of those classes. Okay. I mean, does that make that easier for you, or do you feel as if like it's still just as hard? Also, he's pretty much reading the textbook. Oh, okay. Yeah, sorry to hear that. Sometimes there are teachers that do that. I don't like being talked by the hand. that's fun. It's fine. It's fine for you to feel that way. I get that. I mean, when you were teaching me, you were giving me a lot of details, but at the same time, I'm like, I tried my best to keep up. But I knew you were doing it in your own unique way when you were teaching me. So, like, I understand how you feel. Sometimes you feel like, oh my gosh, like, why am I learning from this professor? Like, if they don't want to teach. Or if it seems like they're not putting that much effort into teaching us. Okay, so calculate the frequency and calculate the area on the surface, on the water surface through which the sound enters the water. Okay, so sorry, I'm dilly-dallying. Okay, so what we have is that the height is. So I guess I kind of drew a little small triangle for myself. So I kind of find it funny because like I'm like maybe we should do the Pythagorean theorem, or like vector, like anything involving vectors. The fundamental wave function is. Oh, so do I have it reversed? Let's see. Velocity is frequency times lambda, the right way, where v is the wave of the sound, yes, and it's the frequency and lambda is the wavelength. Okay, so I got the symbols right. I'm guessing you're saying that I wrote the equation wrong? So I'm guessing I'm supposed to divide it right. So yeah, I haven't done waves in a while. I probably should practice that more. But at least I'm kind of close. I kind of remember the equation. So it's supposed to. So basically, it's frequency times lambda to get the velocity. So for our case, it would have been. So you have to get the velocity over lambda. Okay. Thank you, Walter. Okay, so we can recalculate this. So we have a velocity of 343 divided by a frequency of 0.78. That gives us a frequency of 4.439.7 hertz. I mean, you don't even need the formula for this. It's a bit weird. I mean, usually for me, whenever I do physics problems, I always end up relying on equations and formulas. But then you're probably right. Like, if I'm trying to develop a physics intuition, maybe I probably shouldn't rely on the formulas too much. Well, it feels like I'm back in high school. It's like the teacher is assuming that I'm too dumb to read the textbook for myself. That's fair. Oh, wait, actually you do need it. I think for every physics problem, you need at least 1 or 2 equations to basically solve things. I mean, I think university or of high school physics, I think you need at least like 1 or 2 equations to solve things. Okay, so now we gotta figure out the area in which the sound is going to the water. Well, we do have a height. So the height is basically so we have a height of 8.7 meters. Wow, my 8 is like not looking like an 8. There we go. Now the thing is that we don't have an angle. Like if we were to, if this was a triangle, if we had like triangles here, but there might be a way we can figure this out. Because if it is straight, then that means we can have a 90-degree angle in this side. So the height would be here, and 90 would be here. So if we make the tip here, I mean, I don't want to make it less than 1 degree. I don't want to make it 1 degree or something, because that's gonna be a little bit cumbersome to deal with. You actually need 1 more formula. Yeah, it's like every physics problem involves like another formula like popping out of nowhere. I'm trying to see if I can figure out what the formula is before you tell me, Walter. Because when I see this, I'm thinking of the, I'm thinking about doing like a little trigonometry here. Because we have 90 degrees on this side, if I'm being honest. The thing of it is that I don't want to turn this in, I don't want to turn this top section into like something like 1 degree or something, because I don't want to make it too overly complicated when I'm trying to guesstimate. Because if this is 90 and this is, so I mean, cosine of 90, but that will give us 0, so that doesn't help us much. But then again, like when you're doing science, sometimes it's best not to do exact figures. I feel like I'm so close, but at the same time it's like there's something in my mind that's like blocking me from getting to that right eureka moment, right? I just want to double check to make sure my formula is right for the wave frequency. Because why do I keep remembering it as something different? Okay, so here we go. Maybe it's because I'm thinking of the period. That's probably why I'm thinking of it as thinking of wavelength and frequency in that way. Because I think the frequency is like 1 over the period, and maybe that's probably why I'm like thinking of the equation differently. which is probably why I have to practice more on physics, actually. But then again, like for me, it's like whenever I study math, I try to figure out how can I study math to a point where I can actually go into physics in a very fluent and mathematical way. Alright, Alright, I think I will ask you, Walter, what equation do I need? I probably stalled out long enough. Snell's law, okay. Hopefully I pronounced that right. I probably didn't pronounce that right. Scientists have, like, it's funny that scientists have very unique names. I don't remember that formula well, so let's take a look at what it is. Ah, this relation, okay. So, let's see. Sine of angle theta on angle theta 2. Now we gotta. So I have to figure out what n is in this case. And we don't really have an angle that we can use. I mean, besides 90 degrees, but. Actually, what does Snell's law tells us? What is the description of it? Snell's law gives the relationship between angles of incidence and refraction. When a ray of light travels from a rare medium of refractive index n1 to a denser medium of refraction. Okay, so let's see what else do we have here. Well, we have the frequency of water, so that's supposed to I think that might help us. So is it that we're supposed to use for n1 and n2 we're supposed to use those frequencies? Is that what we're supposed to do? I mean, it feels like that's how it is because like, what do they define n1 and n2 as? Okay, n is equal to. So in this case, when they show it on Google, it says like n is supposed to be equal to. Well, they use light in this case, but we're using sound. So I'm guessing we're supposed to. So if it's the speed of light over the velocity of light in a vacuum, so if we try to use sound in this case, I'm guessing it's supposed to be the speed of sound in a vacuum over the speed of the actual sound itself. I'm thinking that's what we're supposed to do. So now I gotta remember what is the speed of sound in air. Sound. Speed of sound. Oh, okay. Okay, so it's the same as what we have here. So we already have the speed of sound in air, so now oh, maybe we should type in a vacuum. Maybe that might well, you don't. Well, sound doesn't travel in a vacuum because it needs air. So Because I know we're supposed to replace N with like sound qualities. It's not light. So, and if we're going to use Snell's law, then we're going to have to find a way to... So it has to involve wavelength, so... This is a fun problem because it's actually getting me to think about different qualities of things. Because according to what it says on Google, it says N is supposed to be... Well, I'm doing it with light because that's how they say it, but I know it has to involve with sound, so we're gonna just put that there just to keep my brain working. Assume that the temperature is like 20 C because it's 343 meters per second, the speed in that temp. Okay, not saying you need that, but random fact anyway. Okay, I mean, I think that's how it is with science though, because like I think like when people do science, they expect it to be like some sort of like textbook problem. But then, like, when they actually try to do science on their own and try to be creative with it, it's really hard to do it because it's like, wait, I'm not given variables. Like, I actually have to, like, make guesstimates on where I am. This is why I think, like, a lot of people... I think this is why, like, universities make physics students take, like, chemistry. Because when you know chemistry and physics together, it's probably, like, a way better way of, like, finding things that work when you're like out in the wilderness or something, so you can combine stuff together. I mean, it's a good skill to have. I do read about chemistry from time to time, but like I don't focus on it as much as like I do with physics and mathematics. I do want to know, like, I guess, like, what makes chemistry chemistry though. Like, you know, learn the basic stuff. Okay, okay, so we have the speed of sound. So I'm gonna write sound here. So the question is, what goes here? It's not the speed of light. I don't think it's the frequency. The frequency over the velocity? But that would give you the wavelength at that point, right? No. Because then the wavelength, you would have to do the frequency. How many times is that? It would have to be the velocity over the frequency if you're doing the wavelength. So maybe there's a relationship between Snell's law and our little equation on top. I'm just trying to figure out what that is. Well, we do have a velocity of sound. Yeah, this is probably real problem solving. Like, someone comes to you for a problem and you're basically the one to basically try to solve it. Yeah, because all the examples of, like, I don't want to like type up Snell's law for sound. But I might have to end up like doing it because I feel like I'm kind of cheating if I'm doing it that way. Because right now I'm looking at like Google Images to see like how kind of given a visual, unlike how I think. By the way, I won't get mad if you don't want to keep going on or so. No, I'm just like, I don't mind. It's just that for me, I'm just worried about making you guys bored. Because usually when I get deep in thought like this, I don't write anything. I just like yammer. Like I just basically talk to myself a lot. The only thing I'm worried about is just making you guys feel like you're getting bored with like me, like just like kind of like stalled in thought. I guess I have to, no choice. Snell's law. It sounds. Sound waves. No, it ain't boring. I'm doing my own math homework at the same time. Okay, that's good. Because we don't have angles, that's the thing. Unless we're supposed to do, Because the way they do a relationship, it seems like it's like... Let's see, Snell's law applies to sound waves, describe how they refract and bend when passed from one medium to another. So the speed of sound in water and the speed of sound in air. So apparently, I think it's supposed to be the velocity. Because the formula they use is that it's supposed to be sine theta of 1 over sine theta of 2 is equal to v1 over v2. Now, I don't know if that tells us anything, but it might. Because we have one velocity, which is the speed of sound in air. Now, so I think now I gotta ask myself, because we were given the wavelength of water. And the thing of it is that I think the frequency also changes. Because I thought that we could use the frequency to basically get, so it would be like the frequency times the wavelength. And that would give us the speed of sound in water. Like that's the only thing I can see within this, the amount of information we have so far. But I don't know if that's the right approach. Because I'm thinking about frequency and I'm like, does it change when it goes into the water? Or at least when it hits the water, I mean. Let's see. I guess I'll Google it, guys. Frequency. Change with a medium. No frequency of a wave generally does not change when passing through one medium to another. Oh, okay. So that's what I want to know. Okay, so we can use the frequency to basically figure out the speed at which the sound is going in water. So, I mean, I don't know if that's what we need to do, but so the velocity in water. Usually, but thank you for asking, Walter. For me, I think it's like just basically getting hints to like parts of the solution, but I don't want to get the whole solution. It's like for me, it's like when I look at how, if the solution is completely written out, I probably would move my hand like over like one part of the solution. I was like, oh, okay, I'm missing this part. And then I would write it and see if I can like connect the dots. I think that's basically like how you probably best learn this stuff. hertz times the frequency. So hold on. You know what I realized? In water, the wavelength of sound, I mean, it's much longer, which is what's to be expected. And we have hertz. I mean, we have like frequency, and we multiply that, then that means if the math is right, we'll just round this up to 94 meters per second. Is that right? Because that's pretty fast. Usually when I see like stuff like this, now I'm actually trying to develop a habit of like questioning every number that I calculate. Oh wait, hold on. Wavelength, so meters. Sound in the air with the speed of sound in water. I mean, that leaves us with 0.2. We'll put 0.23. I don't know if this side gives us like a trick identity, which is like, but I don't think there's like a trick identity that looks like this. It's like sine over sine, but they're just two different angles. I mean, am I getting close? That's the one thing. Yeah, I think I'm going to probably have to raise the flag, the white flag of surrender. I think I might have to get a hint. Because even though even though it's like we need Snell's law, I just still don't know how to relate it back to like the area of the water, like that will have the sound wave spread. Let's start small. Let's start with a small hint. I mean, like, I want to know if I'm on the right track at least. If I'm going in a totally different direction, maybe I have to rethink the strategy. I mean, I think we got the frequency of sound. We just don't have the area of the water surface through which the sound can enter the water. So I mean, we did get one part of it. It's just that we need to figure out how to get the second part. I feel like I'm seeing something, because when I think about it, if we think about this side, let's just say maybe it might be this, it might be the speed of sound. You need to calculate the critical angle of the total internal fraction. Yeah. Let's see. If we think of this, so maybe we can calculate the angle that way. So we have here, and we have this. That means we would have a cosine over the speed of the sound in air. Well, actually it should be the opposite. So that would be considered the hypotenuse. Height here, so that way we can get this angle over here. So this will be equal to theta over here. So theta would be equal to. This might not be the right approach, but I felt like it was something that I was kind of like ignoring for a while, so I feel like maybe this might be the right approach here. It might not be, but it might be something interesting to look into. 83 degrees. Actually, what mode is this? Okay, it's in degree mode. Okay, that's what I want. The critical angle tells you where the sound waves won't go through water, and the waves will get reflected off the surface of water. Okay. The total internal reflection. And I can tell that you actually need a bit of trigonometry for this, at least, the way I did it. I see. Yeah, I don't know what I don't know if this technique I'm doing is like leading me to the right result, but I feel like it might be getting a little bit, it might help a little bit. 90 minus 80. Wow, like the other angle, let's call that angle phi or something like that. It's 1.5 degrees. Huh. So I'm thinking this angle is like phi, and this angle like right here, which we'll call theta, it's like 85. So it's like 1.5 degrees, which is really funny. Okay, so let's say the sound waves is like around phi's part. Now, if we remember Snell's law, so let's just say that the speed of sound. So let's just erase this part because this one was kind of like we were just like kind of like shooting in the dark here. Okay, so now let's just say that the sine of hold on with that we have this angle actually. We can basically do so we have this angle, then we have this side, so we would need sine of theta and then that would equal to what we have here, well, the opposite, but then we're gonna have to multiply it by 2. It's a O, that's a O, not a 0. So maybe I'll just do that just to make it like more visible for us. No, not H, whoops, I meant to write the speed of sound in the air. So if that's the case, we'll have 3 times sine of 88.5. That gives you, oops, no. That's this one. 42. Let's round it to 43. So 343. Then times that by 2. We're left with 628 meters. So I'll just put A for the area of water. I don't know if that's right, but because I was thinking that because I got this angle right here, I would use that angle to basically, and we know what this height is, and and this side, well, I'm just kind of like assuming that it's like equal to this. Now, of course, like that assumption is probably not valid, but I thought I would like try it out and see where it would lead up to. But that probably isn't right. Well, Walter, I just saw that, I'm thinking that's you that joined the Discord, since you typed it into the chat. Welcome to the Discord. And also, when you guys join the Discord, whether it be from, like, YouTube or Twitch, it would really help me out if, like, you can, change, like, your, Discord names to, like, the names you use on Twitch or YouTube. So that way I can, like, you know who I'm talking to, like, in the Discord server. Like, if it's not too much trouble for you guys. Now, I don't think I got the problem right for the second part, but I feel like it might be. Yeah, I joined in, so if you want, at some point I can send you a picture for you that really explains the problem. Sure. If you want to send the picture, you can post it in the stream material resources channel. That way you can just put all the resources you want to send to help me out with problems there. I probably didn't get this problem right, but sometimes, like, you know, I always do problems on this on the streams, and I sometimes don't get them right, and when I don't get them right, that's usually times when I actually have to learn. So, you know, more times I get it wrong than correct. So hopefully you guys understand, which shows that that's how dedicated I am to learn the material. So okay, so thank you for the problem, Walter. I probably wasn't successful in solving this problem, but it was a fun exercise. It made me kind of, like, more aware of, like, okay, like, what is it like to actually, like, solve a problem that I probably have less, I guess, like, less practice in. And then, like, when you don't have that much practice, you kind of feel as if, like, you have to, like, take a step back and just continuously, like, put in like, I guess, a lot more brain power to it. And I think, like, the more you do the same type of problems, the more you get, like, used to it. So okay, so yeah, we got the frequency right. So thank you for posting that. Let me just... Can I open this in a browser? There we go. Yeah, so I just got the image you sent, Walter. Thanks for sending the image. It actually, like, helps out a lot, and actually is a really good visual. My phone started tweaking, but you can maybe see the vision there. Yeah, we see it. This is the image you sent. So we did get this right, the frequency. Like, we got, like, a close, like, approximation to it. For the second part, yeah, probably. Yeah, I guess I have to surrender. I probably didn't get it right, because, like, the way I did it was basically just looking at the trig relationship here, and if this part was what I thought it was, then I would thinking that probably this part would probably give me, like, one part of the area, and then I would just have to multiply with 2 to get it the symmetric. It's 13 meters squared. Thank you for trying. It's really fun. Okay, so I got it totally wrong. Well, like, you know, I mean, at least I got, like, this basic part. Yeah, it's never fun, like, whenever you feel like you just got defeated, but, you know, sometimes you just gotta accept your weaknesses at that point. I think that's the reason why a lot of people end up like not liking the subjects, because they feel as if like I tried my best but then it still wasn't good enough. But of course, like math itself, like I think like the toxic, well, it could be like a beneficial thing, but for me it's kind of like it could be like a toxic thing too. But it's like I don't like the competition that goes into like science and mathematics, because it's like I'm trying to prove I'm smarter than you, and I'm trying to prove that I'm more brilliant than you and stuff like that, and I'm like, no. I want to learn science and I want to learn math because I believe there's like a certain I guess like a certain wonder to actually knowing that stuff and knowing how it works in nature. That's basically like how it is. But you get better by practicing though. You get better doing stuff you can't do though. Yeah, like that's basically like the point. That's the reason why I'm putting myself through it, even though I know I'm not going to get every answer correct or I'm going to get lost. If you do stuff that you know, you can do stuff you will never improve. Yeah, that's also another thing too. I think it's just basically getting used to the fact that like when you fail at a problem, like you have to find a way to basically like say like, hey, I'm not good at it, but at the same time I'm trying. And I think that's the thing that like you just have to keep telling yourself, because yeah, you can be down on yourself a lot, but at the same time it's like it doesn't help. Okay, I think we'll continue on with some of these problems. Because actually with physics, I actually have to practice more in physics, like basic physics, like the physics you learn like in university or high school, whichever. Like I would remember the equations, but I would never like be able to, I guess, like implement like more complex problems. I would probably remember the equations, and then like if there was a number that basically gave certain variables, I would try to like find equations that require the less amount of variables and then just put it into the equation. But then again, like I haven't developed my physics intuition, because I kind of probably rely too much on the math. I am 35. I am 35 years old. I have no problem telling you guys how old I am, because like this is the reason why physics is a hobby to me. I don't want to look at it anymore. Because I think for me, I was actually hoping that my method would solve it, but apparently it didn't. So I'm like, yeah, that's not right. Yeah, I know I'm probably gonna be a lot older than probably all of you lot. That doesn't bother me though. I'd rather be like, you know, the person that's like the old uncle that basically is willing to listen to you guys out whenever you are like you want to understand some stuff, like whether you want to gain some insight on my experience and stuff. Okay, here's a diagram for the relation R and set A. So we have A set of 0, 1, 3, 4, 5. Now the relation, I'm just gonna basically do it the way I see easier. So 3, 3, and 4 to 3. This one is like 4, 2. Then we have 5, 0. And 1, 2. And 2, 5. But respect the grind, man. And I do think the same age as you, I like I love math. You like I I love math and physics and chemistry because just understanding how everything works and why they are what they are. Yeah, absolutely. Oh, hi Titan, how's it going? It's been a while since I've seen you. I mean, I didn't stream yesterday, so it's good to see you on the YouTube chat. What's the best part of your day so far, Titan? Yeah, unfortunately, I can't put both the YouTube chat and the Twitch chat together because I don't know how to do that on my screen. So, like, all you guys on YouTube, you're actually seeing the Twitch chat. I gotta figure out how to put the YouTube chat on as well together. Okay. Actually, I probably should check because the last problem we did was like this. So, but this one's number 4. I think we can check on Quizlet. Where is it? Relations. Problem number 4. Section 1.1. Oh no, this is the 3rd edition, I think. Because this one's the 2nd edition. So I think we can probably check 5. Maybe 5 would be better to look at. Solutions. Yeah, if you guys ever like want to like show me a problem or something and have me do it on stream, I don't mind doing those. Especially if it involves like physics and mathematics, so... Chapter 9... number 5, okay. Okay, so we did write them right. Okay, so whichever one the arrow is pointing to is like the one where it comes from. Yeah, I think everything looks right. Okay, I think these two problems are fun because it's like you look at a picture and then you basically the math like kind of pops out from the picture. It makes you wonder. It's like if you like, I think the mathematical techniques, like let's say if you're looking at an actual picture from like, you know, like Google, like from Google or something, like a picture of like say like a random city or something, right? It'd be cool if like basically like, oh, every intersection, every line, every pixel is like reduced to nothing more than like these little bits. And I think that's pretty interesting. Okay, Walter, thanks for stopping by. Thanks for like sharing out your interesting problem with us, and thank you for all your help, because I feel like if it wasn't for your hints, I probably wouldn't have gotten a little bit into that problem that we were doing. So yeah, this chapter is so traumatizing. what do you mean, Titan? But yeah, you have a great day, Walter. Thanks for stopping by. And thank you for the follow. Much appreciated. Hope to see you again sometime in the near future. Yep, have a good night. Have a good night. What do you mean by this chapter is a traumatizing Titan? Like, just relation problems? Is that what you mean? Okay, Okay, back to relations. So we got 5 right, so I think we're getting a little bit better there. Number 6. Ooh, number 6 is involves modular arithmetic, so might be a very interesting one. I don't know why it keeps doing that. Okay. The problems are making me see double. Okay, concurrence modular 5 is a relation on the set A is equal to the integers. In this relation, x or y means, okay, so write out the set of R in set notation. Okay. Oh boy. So we know what A is. A is the set of integers, and the relation we have. Maybe we have to write it like X is an element of A such that X is equal to, well, actually we have to define what Y is too, so I'm guessing both X and Y are both integers, so where X is equal to Y mod 5. In this relation, oh, wait a minute. When I think about it, because there's supposed to be an ordered pair. I forgot about that. So maybe it has to be like X and Y such that I lost 15 marks in my term exam because of this chapter. Oh. Like, what was the thing that made it hard for you? Because, I mean, it's kind of challenging for me, too. So, you know, I'm probably in the same boat that you're in, Titan. Maybe we have to write like At first I struggled to know the use of this chapter, and it felt pretty useless, but after using it while coding, it became easier. Oh, okay. That makes sense. What problem is this? 6. Let's see if 6 is the same question here. Because I know this is the second edition and it's not the third one, so actually maybe we can look for the third one. Let's see if third edition. Let's see if they have it here. No, they don't. Okay, so yeah, I think with like any pure mathematical, like pure proofs math course, it may seem like you're asking yourself, why am I learning this? Because I'm only learning this for an application type of thing. I don't want to like learn it rigorously like mathematicians. And you know, like that's the reason why I learned math proofs too, is like I want to learn it for like theoretical physics sake. It's like I don't want to be rigorous. But then again, like most people that do math, it's like, but rigor is where the cool stuff happens, because you actually prove stuff that nobody else can prove, you know, and it will remain true forever. But maybe number 7 is like a similar question, so maybe that will help us. Write the relation less than on the set. A is the set Z as a subset of R of integer. Okay. This is an infinite set, so you will have to use some set notation. Okay. All right. So I'm guessing we're gonna have to write this as the indicator, and then actually, like Titan, I'm wondering, like, how did it become easier for you when you were starting to code with it? Is it because, like, you had to do relations within the coding? Is that why it became easier and made more sense to you at that time? use relations to organize a huge data. Oh, okay. That makes sense, because you want to make sure that everything is like related to a certain area, so that way you don't mix up everything that's in the computer or whatever it is that you're working with. So like this data goes this way and this data goes that way, but it depends on where it came from. Like, you know, like what data did the user provide that can link it up to make it more organized and categorized. Here. Come on, where are you? Okay. Okay. That probably makes a lot more sense, actually. So then we gotta write it like this, where it's like y is less than x is an element of z, or a, it might be a. Oh, the natural numbers. Well, I think that will do it for today's stream, guys. Thanks for joining me today. I'm not sure if I'll be streaming tomorrow. There might be like some things I might have to do tomorrow, so I will update you guys on Discord to let you guys know if anything's going down. That will change plans for tomorrow. But thanks for joining me today, guys. For all those that are in YouTube, in the YouTube live chat, thanks for joining us. If it's your first time on the channel, you know, consider hitting the sub button and hitting a like, and leave a comment down below if you're watching this after the live stream. And if you're on, and also the links for the Discord, as well as my Twitch channel, as well as my gaming channel is also in the description down below. If you're watching this on Twitch, you know, drop a follow. I really appreciate it. In addition, I will also post the Discord in the chat, along with my video game channel and my YouTube channel in the Twitch chat, so you guys can actually access those as well. So yeah, so I will keep you guys updated for tomorrow just in case. But thanks for joining us today, guys. And always remember, everyone is precious. You guys are just as precious as everyone else. And I will see you guys in the next stream. So take care, guys. Bye-bye.